So let's start the problem. Valid binary search tree. So you can see the left node will always be the less than the root node, and right node will always be greater than the root node. So you can see, means we are taking two variables left and right. Whenever they are null means there is no limit. The value can be lower, very lower, so we are not limiting. But when we come to the root node left, then what is the right side of limit? That is the root. Now right is root, so value will always be less than the right, and left is still null, so left can be anything. So when you come to the right side, then you are limiting the left side with the root, and right can be null. So let's say we are passing null and null initially. So if the left is not null, and the value should always be, and the value should be greater than left. So you can see inside the left is 2, so value should be greater than 2. But if you find less than or equal to left node value, you will return false, means you have break down the properties of the binary search tree. And that same applies to the right side also. If value is greater than right side, means you are outside the limit, and then you can say you should return false. And also check the condition right is not null. If right is null, then there is no limit, so no need to check, that will always be true. And we are checking for all the subtree, and we are return ending. That means if any of them becomes false, that will return false, else we will return just true. So let's see. Okay, so you can see runtime is 0 millisecond and faster than anyone. So that's about that problem. And we can try one more thing, that is using the in order traversal. So when you find in order traversal, that should be in the sorted order. That is second approach. So that also might be efficient, but you need to traverse 2 times all that data, and you also need some space for storing that sorting. So that is very much efficient approach to go with an interview.